Welcome to today's live stream. Jeffrey Palermo, your host, and this is our very first lead engineer live stream. Getting the lighting going as everyone's coming into the stream. So what we're doing today is a private test run for the lead engineer live stream. We're going to make this public, but you heard about it because you or one of your coworkers or manager happened to be already using some of the ClearMeasure tools and educational material, and so we are adding this. Here's the mission. We understand that there's plenty of uh, educational avenues out there. You can pretty much learn any technology on YouTube or all kinds of other avenues. However, when it comes to actually being in a leadership role, there's not as many professional development opportunities out there. And so um, we do interactive peer forums for software architects. We do it for software executives. And now we're adding a new venue for actual software developers who are looking forward to a time when they can be in a leadership role. And so, whether you already are a lead engineer or a senior engineer or any other role, but you're looking forward to being in some type of leadership role on a software development team, then that's what this avenue is. And so, what I wanted to do today is um, is open this up, and I'm going to show how you should think about artificial intelligence and get it set up on your local computer. That's what I want to show you. And everybody, the entire industry has been on this journey, and so I'm gonna show that. I'm gonna show some large language models running completely locally on my computer, and I'm going to talk about how to integrate that with your .NET software applications. Because when you're a lead engineer, you need to effectively guide the other developers on the team on how to write the code properly and what patterns to use. So I had to fix my lighting. So we'll go ahead and do that. All right, let's get a quick announcement out of the way. I recently published another book at the end of last year called The Five Pillars: Leadership for Effective Custom Software. And you can go to bit.ly/The Five Pillars Leadership, and you can find that book. It's on Amazon, hardcover, softcover, Kindle, and ebook. And if you would like a free electronic copy of the book, you can just put a request in chat or go to clearmeasure.com and request that, and I'll be happy to get it to you. All right, let me get the. Oh, and we have a study guide that goes along with it so that you can talk about it with your team, or it's really studying the team. But let's get PowerPoint out of the way because I really want to show what AI looks like locally, and then we'll take questions. So the chat is open. Put some questions in if one of you wouldn't mind just putting a confirmation in the chat that you're hearing me loud and clear, and you can see my screen, then I'd appreciate that if somebody would put that in the chat just as a confirmation. All right, let me make this bigger so that you can see, and I'll shrink myself. Do that. It will shrink me up in the corner. All right, this is a large language model running locally, kind of like ChatGPT. How is the weather? And it just runs locally, and it kind of outputs it. Have to warm up again. And there it is. I don't have the real-time access to the weather. Okay, great. And so that's what it is to run locally. And I'm just going to show a few things real quick and then go through them. And here is a test that actually connects to Ollama running the same model. And this is the prompt. What can you do? Answer in JSON format, only list two capabilities. So I am going to switch right here so you can see my keyboard. and Control TR. I'm using ReSharper shortcut keys, so we're going to build. And actually, it probably makes sense to have larger screen. All right, and we ran that in Visual Studio, and the test passed, and I just remember I was just doing console.write, and boom, there's the capabilities. Okay, if I go back to this and just go up to prompts, what can you do? Answer in JSON format. You look, we're going against the large language model, and I'm getting the same thing. At the same time, it's a different way. If I'm using Open Web UI on top of Ollama, and if I go to if I go here and ask, what can you do? Answer in JSON format, only list 2 capabilities, and I put that in the sort of the chat GPT format, it lists the same thing. So I have, by the way, 100% of this is running locally. I'm not going out to anything on the network. This is 100% on my computer. And you can see the different models that I have loaded. The 5.4 is 14.7 billion parameters. It's a little bit too big for the hardware that I'm running now, but I'm going to show you this journey. All right, now if I'm just going to show you a bunch of stuff that you all need to see. All right, this is my computer. All right, and I got the CPU. By the way, my computer's 6 years old, and there was some time ago in 2018 that I realized that I was really taxing a laptop to the gills, and so I actually got myself a desktop computer, and so it's a Core i9 9900K, which was good back then, but not so much now. And I've got 64 gigs of memory, and I've got a number of hard drives. The D drive is where the models are. So when you see this spiking, it's because we're doing some model work. And then GPU 1. So we have the Intel GPU that I don't use, but GPU 1 is an AMD GPU that is back from 2018. And this one can support 3 monitors per GPU, which all the modern ones can support 3 monitors now. But I wanted to run multiple monitors, and so I got a decent one at the time. I don't do a whole lot of gaming, so it was really for just being able to run a lot of good monitors. I've got one 2K monitor. No, I think it's 4K now, and then 2 full HD monitors. All right, and then this is running all the displays. GPU 2, I just put this in more recently because I wasn't happy about the performance, because the AMD, of course, this series, it didn't have any support for, it didn't have any CUDA cores, and it didn't have any support for giving the AI processing. And so it was just maxing out my CPU, and it was really slow. And so this NVIDIA GeForce RTX 3060, it's nothing special, actually. I got it at Best Buy. I think they're running $250, $300, which is a lot of money, but it's not the money that an RTX 4090 goes for, or the 50 series. And so if you're running on a laptop, I do have a Surface laptop that has an NVIDIA graphics card in it, and that really helps. So the laptop NVIDIA cards are good, but that really is key. NVIDIA is the absolute, just top of the food chain right now in performance. And so if I were to go and send this again, you'll see the NVIDIA card go into 100 very briefly. And if I was to say, what is your hardest prompt for a LLM to process. You know, you can do some discovery here. And here's the prompt. And so, okay, so if I literally copy this and paste it, then, well, we can see NVIDIA, but that wasn't actually, that was pretty easy. But let me talk about what is happening here locally. All right, I'm going to show you a few things, and let me pull up the browser. Okay, so this right here kind of looks like ChatGPT, and it's running completely locally. But what the heck is it? It's OpenWebUI. So you just download it and install it. I'm running it on Windows. I'm actually not running it in Docker. I literally just kind of installed it. It took a while to install, but once it's installed and running, it literally runs from, you know, just start at console, and the command is UVX OpenWebUI. Now it's a whole lot of Python, but the install, you don't have to know anything about Python. You just run it through PowerShell, and you give it a data directory. I put it on my D drive, and then the serve command line is going to open it up, run it, and then it starts on port 8080 right there. So whatever your IP address, port 8080, and then you can run it, and it will automatically detect if you are running Ollama locally, and it'll find it. So Ollama is actually running in the system tray. I've installed that locally as well, but you'll want to download and install Ollama. So if you've never done this before, just download it on Windows. We're all .NET developers, literally download. And it's just going to download an Ollama setup, and you just go through the setup. Next, finish, and then you're done. Okay, so I'm not going to download it again. But once you're done, you open up a PowerShell window. I'm going to Control C and then Control D to exit. And then you literally have an Ollama command line, and you can do a bunch of stuff. And Ollama list is going to show what models I have downloaded. And yes, I have downloaded these set of models, including the new DeepSeek R1. And you can see the size. Quincoder 2.5, 19 gigs in size. My computer actually doesn't have enough RAM. It doesn't have enough memory to actually run that model locally. It gives me an error, which is fine. And I can't run DeepSeek V3 because that sucker is 400 gigabytes. So I don't have enough hardware to run it locally. But all these other models are free and open source. And through Ollama, you can go to their model catalog, and you can literally download, all the ones that you see here. For myself, I like Mistral. I like Llama 3.2. 5.4 is a little bit slow on my hardware, but I'm sure it's great. Gemma. So all of these are text based. All right, and they use up this much hard drive space. So I actually put in a new hard drive because you're going to have to manage your own hard drive space. But if you do Ollama run DeepSeek R1, it takes a little bit to spin it up. Ooh, I want to show you what it's doing while it's running. You can see the hard drive, disk D. You see the hard drive because, I mean, look at that size, 4.7 gigs. It's loading up a whole lot, and it's kind of ticking up the memory here. And now it's ready for a question. So what can you do? And DeepSync is a reasoning model, so it's going to do a little bit of thinking and then kind of do that. All right. So let's see. What is 2 plus 2? Of course, models aren't very good at math, but all right, it's gonna have a lot of output inside this think tag, and it's almost like it's trying to reason. All right, so 2 plus 2 equals 4. That's great. So I can do Control D to get out of here, and Ollama list. No. Ollama list, and I'll get back to. I think I'll get back to Llama 3.2. Okay, what can you do? There we go. All right. So that is running locally. And all right. So I've got those processes. And by the way, the Ollama client, it actually runs locally in a little system tray icon, and it's very easy to find the server logs. So there is an environment variable that I went and changed so that I could retrieve the models, so I could download the models into my D drive, because my C drive, I didn't want to put all that, I didn't have enough space on my C drive. So there's an environment variable called Ollama models, and I put the value D LLM models, and then I restarted. All right, you can see Ollama host is whatever local is 11434. That's the host. That's the standard host. That's how this Open Web UI is able to call out to Ollama in order to do it. So let me actually draw what the pieces are. I want to draw this for you. Let me see if I can open whiteboard real quick. Okay, and I am doing, new. Let's see here. Bear with me. Over the blank canvas. All right. So the whiteboard actually, since I'm sharing this screen, I have to open my mouse. All right. So that's not that. I don't need to connect on the web. All right. So you're going to have one box that's, well, what is this? You know what? My pen doesn't work on this monitor. That's the problem. Okay. So I'm not going to do that. I'm not going to do that. I'm just going to talk through it. Okay. All right. We have Ollama, which is just a server daemon, and these are the logs for Ollama, and it's running at 11434. And by default, there's no SSL. You have to kind of set that up. So if I were to go here, then it's just going to say Ollama is running. Okay, that's it. Then I can run a client, and I can run Ollama 3.2. All right, and just from that, it's going to call and use it. All right. From this other session, Open Web UI, this is running an additional web application on port 8080. So if I go over, notice that I'm on port 8080. And when it starts up, it expects the Ollama daemon to be running, and it's going to query list, and it's going to say, how many do you have? And there we go. And then I can also, run. And this web application kind of gives you what you might get with ChatGPT. And it has a lot of information, and it can do a lot of stuff. So if you want a local ChatGPT and you're just asking about stuff, then you can do all the stuff that ChatGPT can. You can say, write a 200-word paper on Andrew Jackson, and there it goes. A whole bunch of stuff. All right. You can paste in, you can do all kinds of stuff. All right. And it just got updated since yesterday. Fantastic. All right. So let me stop that. Now, what I want to do is show you in Visual Studio what's more interesting, which is how do we integrate it with our applications? How do we integrate it? And we do it by using Ollama API client which is provided by Ollama Sharp. Okay. And so we go to NuGet and we download Ollama Sharp, and then we have a few using statements, and literally we can run it here. So we call the Ollama client, we give it the URL to wherever Ollama is running, which is local. And then a new chat request specifies the model that we're targeting, which is Llama 3.2. And then we send it a new message. And a new message has a whole bunch of things depending on the model. But in short, we're just going to give it this prompt. And then we're going to say client.chat, and all of this is async. And it's all the tokens. So we have to do to a blocking enumerable and then iterate through. So if I do Control TR, then we can see the output. And this is where we start thinking about how to integrate it into our applications. And we're going to have to integrate it with just regular code. And so it's not just going to be a free-form prompt. It's going to have a whole lot of parameters. And so to learn about the parameters, we can ask the model. And I like to go to a new chat just so that the history doesn't cloud it up. What parameters and tools do you support? Oh, great. Okay. Give me a JSON prompt using your tools and parameters. There we go. All right. So if I just literally took this and I copied it and I go to a new chat so that there's no context and I paste it in here, then what's it going to do? There it is. So now it's actually taking that as the instructions. And if you look up, the instructions were conversational. Well, let me paste it again so we can see better. All right, the prompt was, it's a text prompt. We're specifying English, conversational, and we want a topic of exploration, and it's just going to generate it, you know. The prompt, basically, this is what it's saying. So you can actually use the model to help you learn how that model needs to be prompted. And then you can literally take a JSON snippet, and over in Visual Studio, this is how we would, so instead of just text, we would send JSON in, and we would receive JSON out if we specify that. If you think about it, that's how HTTP web services work. HTTP web services work by receiving some text over JSON over the Hypertext Transfer Protocol, HTTP, and then the server does something and returns back an HTTP response, which has some headers and a whole bunch of markup, and then the program that receives it parses the markup. So this is how we need to think about it. Let me transition to a little bit of architecture for you, just so you know how to think. And I'm going to use a plant UML architecture diagram that I have here. And this is a software architecture, a online auction piece of software. And this is just the source of the architecture diagram. And you can see inside the system that we have a Blazor WebAssembly client, we have API process, we got SQL Server database, we have an Azure Blob container, we have an image tool that operates on the data in the blob. We have an auction gateway tool that's running to a different database. So you got a bunch of things going on. And so I want to talk about what the architecture looks like when you are going to augment it with an AI large language model. And I'll probably go over versionable architecture diagrams on a different live stream. But if you've never seen Plant UML, it's a way to specify actors specify system boundaries in different containers, like a database or just a process that's running. And then these are all the lines in the diagram, the relationships. But let me go to this modified one. And what I've done here, I've done two things. I have created one more container DB because effectively a large language model is a file of data in a certain way. It's a file. If you changed out the file, then it would have different data. So I'm using container DB llama and then text llama 3.2. And then if I zoom in, this part of the diagram, the server process that's running our .NET program and web APIs that our Blazor client are talking to, we have another, just think of it as a database. Architecturally, think of it as a database at a highest level, and this is Llama 3.2, okay? Now, the mechanism that we call is through the OLlama server. But if you think about it, just think about it architecturally. When you format a query, a SQL query, and send it to SQL Server, you're not directly talking to the SQL Server database file, which is the MDF file that's sitting in storage somewhere. Just like LLM, ultimately, those models are a file. By the way, I didn't show you where the file was. So let me just show you where those files are. And it's on the D drive, LLM models, blobs, and these are the files. If we sort by size, you can see these are the actual file. I can tell you right now, this is 5.4 from Microsoft because it's 19 gigs. And then we have some other, manifests and checksums and all that. But basically, think of these as your big database files. These are the models, and manifests go along with it, and registry. I don't poke around in here, but all of them have, like Llama 3.2 that we were using. It has a little manifest file, and I can show you what it looks like. And it's just some JSON. Boom, there it is. Okay. And that's about it. All right, so as I get rid of that, when you send a SQL query to a database, you format it in a certain way so that it is an appropriate database prompt. Select some number of columns from table, inner join table, where column equals column, and it's a bunch of text. And the way you format the text is going to get you very, very different results. And we're not going directly to the database. We are using a library. We're using probably Entity Framework, and it is actually crafting the real, all of the envelope for the prompt. And then it is sending to a SQL server that is running somewhere. We have a connection string to a SQL server, and then that SQL server accesses the database file in order to get a response to the SQL query, which is our prompt to a database, and then return it back. And it returns it in a form that has to be parsed, and we have to figure out how do we want to show it to a user and reason about it. Same thing with the large language models. It is a dependency where we want to figure out which running process in our software application do we want to have a dependency on our AI server, which is OLlama. It's not SQL Server, it's OLlama. And the connection string is that is basically the same as a web API. It's a URL, it's a IP address or host with the port number. And so that is going to connect to our OLlama server daemon, which has to be running somewhere. In my case, it's running locally, just like I run SQL Server locally. And we pass in a prompt, which includes the model name, Llama 3.2, which effectively think of as the database. And then it includes the prompt, which is a query. And OLlama is going to go and fetch that particular model, and it's going to apply the prompt, going to get the results, and then it's going to send it back. And then we use the Llama Sharp library to to actually parse it and turn it into .NET objects or Ollama Sharp. Okay. So when you're running this locally, pretty easy to set up. Just set up those same things, and then you can start integrating this with an application. All right. Oh, thank you, Eric. Is that better? All right. I saw the comment. Yeah, I have to go full screen. All right. So let me just wrap this. And just like any other piece of software that uses SQL Server for a database, you're going to use the same patterns when crafting integration tests. Your unit tests test logic of your own C# code, but you need component level integration tests in order to make round trips to your SQL Server database and make sure that the data got back properly. Same thing with your large language models. And it's going to be a challenge because the architecture of GPT, generative pre-trained transformer, which is the technology that all these models kind of sit on, it's by its very nature, it's probabilistic instead of deterministic. So a SQL Server, if you give it the same query over and over and over and over again, if the data doesn't change, then you'll get the same thing back. With the large language models, you're very often going to get something back somehow, and so you have to craft your prompt to get back consistent results. And I'll give you an analysis how to think about this. If I go to a new chat and I say, what is 2 plus 2? Just something, and I didn't prepare this in advance, so I'm just assuming okay, 2 plus 2 equals 4. And let me do it again. 2 plus 2 equals 4. Okay, now what if I say 2 plus 2? Okay, well, it wasn't doing, let's see. You can retry. I need to give it something more significant, like, there we go. All right, so here it's giving me a single equation and a number, and here it's giving me a full-on explanation. But go back to, what is 2 plus 2? Without a question mark. I've already told you that one too. See? So even here, it's non-deterministic. And so it just takes some experimentation to learn the way that a particular model was trained so that you can get some sort of consistency. Now, don't expect deterministic responses back from a large language model. It's not going to happen. If you need to store some data, and if you need a search tool, use a database. But if you're gonna use your imagination, you're gonna think, okay, how can I use this in my software? Well, if you have a software system that has a whole bunch of PDFs or a whole bunch of images of something, like in the software auction. The auction software I showed you the architecture for, we had an image tool. Let me show you that again. And here it was. Yeah, so in this diagram, we have a image tool that has a whole bunch of pictures, JPEGs and PNGs in Azure, and the AI tool, the image recognition, that would be a very interesting feature to just be able to augment a process that just on an asynchronous basis goes through all the images as people upload images as they list an animal for sale at the livestock auction. It kind of does some analysis on the image itself and annotates some additional data in a database about inferring something about that animal. Maybe if it was listed as a bovine, as a steer, then maybe we can try to verify that it is in fact a picture of some type of cow, steer, that regard, and not a picture of a lamb and getting things mixed up. So that's one example, one particular use. All right, now I want to switch to and just show you another tool that you really should be using, which is Copilot for this. And Copilot's going to help you generate. So let's see, if I was to, I already have one test in here. If I was to come here and say, alt/ generate a test that calls Ollama with a math prompt. All right, enter, and it's going to scroll. Yep, there it is. And I'm just going to do control enter. All right. So there we go. Now, I will tell you right now that it looked very similar to this because I already had this code here. And so, I'm not even, you know what? Let's see what it happens. Does it run? Well, let's run it. Sometimes it will, sometimes it won't, but it'll get you down the road. Come on. Running and math prompt. Oh, yeah. Okay. It ran flawlessly. Yeah. So, the key with using ChatGPT is not about the model it's using under the covers, which it's using GPT 4.0 under the covers, and you can kind of change that. Let's see, GitHub. Yeah, you can kind of change to Claude 3.5. It's under preview or some of the minis. You can do that. But if you're over here, you can just chat with it. I think it's more interesting to generate some code that can help get us down the road. And you're going to have a lot more luck when you're in a file that already has some code there. For example, if I was to, let's just say I'm going to create. Do I want to do that? Yeah. All right. So, AI tester. All right. I'm using InUnit, so it's going to be a test fixture. And if I was to alt/ generate a test that calls Ollama using Ollama sharp and hit enter. Now, there we go. Okay. So I'm going to accept this code. Now, is this in the library? Create type? No, it's not there. All right, this right here, I'm in a file and there's no other context there. And so GitHub Copilot is going to just go into its raw training in GPT-4 and say, oh, how do we call Ollama with C#? And this is what it comes up with. But that's it. Whereas when we were over in a file that already had some additional code, we had already established a pattern by which we call Ollama. We're using the Ollama API client, okay? Well, it basically used the same pattern. So when you are just getting started in a new code base or a new file, you might as well just go online and be using GPT-4 on copilot.microsoft.cloud and just asking it for code samples. Hey, how do I call Ollama with C#? Because that's about what you're going to get. The power of Copilot comes into play when you have a good amount of code that you like in your existing code base, and it's going to look at that code as context and it's going to give you code that is similar. So if you have, switch over here. If you have code that you don't like in your existing application, then Copilot is just going to use that to generate and suggest to you code that you don't like, right? That's how it's going to happen. So it's really important. And getting back to you as a lead engineer on the team, in order to equip the other developers on the team with these tools, you need to structure it properly. You need to think about architecturally where you want it to fit. You need to have the right type of understanding about where it fits in your existing architecture. Again, these models are data files. They're going to sit on a hard drive somewhere, just like an MDF file for SQL Server. And so use those same patterns when describing the architecture and then the tools. And then the question is, how do I use it? Well, it's just like any other dependency. It can do something for you. You're going to communicate to it over HTTP. You're going to use the C# helper library, and there's more helper libraries, but Ollama Sharp, if you're just getting into it, that's just go for that. It is so mature at this point to start learning. And the big vendors are in a race to kind of put AI tools out there so that they can capture market share, and that the dust isn't going to settle for a long time. But you want to make sure that you can play around and learn about this, and so get all of your developers set up with these tools locally. Don't waste money on ChatGPT or Azure. I mean, just playing around and sending a whole lot of things. You can run up a good Azure bill using the Azure Open AI services, and in a production environment where you need to scale up, and that may be fine. But if you're just running locally and start learning it, then don't spend the money. Put everything that I just showed you, everything is running on my box locally, and that's where it is. So I do want to show you, let's see. I have some pictures of my NVIDIA upgrade. Hold on, let me pull those up real quick. Yeah, here we go. Get the right monitor over here. All right, here we go. So, and it's upside down. That's great. All right. Well, this is my 2018 Alienware computer, and it had dual Radeon graphics cards in there, so I could support 6 monitors. And whoops, wrong way. And so I took out the bottom video card. I have an Elgato capture card, a 4K capture card kind of in the middle. I took that out, and I was grateful that I had a power supply that actually had an additional GPU connector, so I didn't have to futz with my power supply. And yeah, my power supply kind of had a 6-pin, and then it had an 8-pin. So I put the GeForce RTX 3060 down below. I just left the Radeon card serving the monitors. This GPU, it has no monitors connected to it. I literally put it into my PCIe version 4 slot. It's literally in there as an AI processor. So you don't actually have to chain. If you just have an extra slot, then put it in there. I tried putting it in as my regular video graphics card, and then I changed my mind. Okay, so that right there, I just want to show it to you. Now, for hardware, just to give you some context, the lowest RTX 2060 is going to give you 51 tops. All right, that's over the 40 tops that Microsoft is mandating for all of its Copilot branded computers and the Snapdragon computers. And so it's kind of related. Well, it's supposed to be related to teraflops, but it's not. But it stands for trillions of operations per second. Okay. And so the NPU that Microsoft is mandating with the Snapdragon and the Intel, the latest Intel processors that have an NPU, they're trying to push a standard of 40. But you see the 3060 that I got with 12 gigs of RAM, that's at 109 trillion of operations per second. And if that is perfectly fine. I mean, really, any of these right here will be perfectly fine for a developer's workstation. It's gonna be perfectly usable. Now, when you're thinking about hardware that is serving multiple people in a server environment, if you're not using Azure OpenAI, but if you're thinking about just setting up a server of sorts, that's perfectly fine. NVIDIA kind of owns this space right now. And the 5090s and 5080s you can't get right now because they just came out. And even the 40 series are kind of hard to get. But I mean, just look, if Snapdragon is coming out with between 40 and 100 tops, NVIDIA is 10 times 30, 10 times that. So that's what you need to look at. Now, for a test lab, for test environments, non-production, the NVIDIA Jetson is actually really interesting because it runs a distribution of Linux. It's a little tiny server, but you can run the Ollama server on this guy to do all the processing. And just think about it. If you're running a database, you need some hardware that can run the database server. Well, this hardware has the NVIDIA AI chips in it, and it can run the AI server. Okay, think architecturally. You need an AI server, and it's going to have the LLMs, and you run it here, and then your other components connect to this guy over the network using HTTP, using the network address with that special port, and then your .NET code calls from wherever it is to this. So in a test environment, this is also an option. So if you don't have the ability to put in a NVIDIA GPU into your developer's workstation, this is another option for just putting into your own testing lab, putting it, plug it into your switch, and now you're on the network, and you can connect a good SSD to it so you have enough hard drive space for the models, and it's running Linux, and it's running the Ollama server, but then you can do all of your development locally, and when you're running and testing, it's just calling over the network through that port and using this, and you have a little AI server on your desk. So that's a really good option. That's a really good option. And then, the Jetson AI Lab, Ollama is a first-class AI server to install on it. All right, so that's what I wanted to share today, and I really wanted to kind of ground you on as a developer and how to set up the other more junior developers on your team for AI development instead of just using ChatGPT online or Copilot, but how do we actually start running this locally? And by the way, I didn't spend money for any of this stuff except for the GPU. All of the models that I talked about are open source models, and there's more to come. So I wanted to share how to get running locally and without spending per use. So as we kind of close up, thanks for coming to the first Lead Engineer live stream. My hope for you is that you take the next step in your career and get and excel in a lead engineer position. And so with that, if there's any questions that I did not answer, then I'd be happy to do that at this point. All right, switch over to the questioning. All right, any questions that come through? think I answered all the questions in line. All right. And if there's any comments on other topics, I've got a whole list of things that any software engineer who's looking to be in a lead role on a software project is going to need to be good at. But if you have any questions or potential topics that you would like a future live stream to be, then just let me know. And you can find me at jeffrey@clear-measure.com. It's my email address, JEFFREY. But just let me know, and I'd be happy to do it, because my goal for all of you is that you'll help your team move fast and deliver quality, and ultimately have a great time running your software systems in production with no drama, and have a great time in the field of software development. All right. Well, then we will conclude this one. Thank you so much for being with me, and God bless, and have a great weekend.